All right, here we go. Last one before we change topics slightly. Finally come full circle here. We want to find the acceleration given some kind of information about forces and masses and some other things. And so if we think about, excuse me, what we learned before, acceleration can come from net force divided by mass. So we had that originally. We were talking about people pulling on the sled trying to get it across the road, or eventually when they were fighting over it. You may have remembered or noticed at the time that there was no friction because it was a frozen road. So that's finally coming back, and we're going to see how much of a difference there is when we don't know what the friction is. All right, so here, net force, we've got to work down and find following, similar methods from question 7. Net force is going to come from whatever person is pushing, pulling, trying to make stuff go, and then whatever gets wasted by friction, we'll see what's left over. Great news is we have F1 right now, just like we already have mass. So, kind of running through, we've got like half of everything we need. So, dig in, work a little harder, see what you can get to. All right, well, look, I don't know the force of friction right now, but I got some rules and some formulas and some ideas. I feel like we can probably get there. All right, so by definition, the only real thing I know about friction so far is that it comes from taking the coefficient, this decimal mu number, and multiplying by normal force, which, mu is here, right? I have that coefficient of friction, big long set of words, but that's the decimal number, that's mu. So I have that. What's normal force? We don't know. All right, so look, I know it seems like we're digging a deeper and deeper hole, like we're getting nowhere, and we're taking a long time to get nowhere. But if I look at normal force, all right, normal force on a flat level surface is equal to the weight of an object. And if I had the weight of the object, I'd be very happy because it'd be the first time that it happened and would give me a shortcut. Unfortunately, no. All right, so I don't know the weight of the object, but we've done this several times. It should not be a surprise. Almost should just change the formula and then make it mass times gravity because it seems to be what we keep doing. But this thing, finally, we can get to because look, we have the mass. We understand what gravity is and what it comes from and what value it should have. Yeah, finally we can do something. We can get an answer. We can make progress. We start on our way in, and we're good to go. All right, so let's do it. The mass here is 201 kilograms. Gravity should hopefully be 9.8 meters per second squared. That's going to give us our normal force. So multiplying these, 1969.8. All right, and fixed one of our issues because now, hey, I know normal force. I was looking for normal force earlier. I was trying to talk about that and do some stuff with it. I couldn't, but now I can, right? So let's see where else we can go. What else can we do? How else can we help? Well, mu is 0.29, and the normal force is 1969.8. And lo and behold, as predicted, once we kind of start chipping away at it, we can keep doing stuff and getting places. But we multiply these, we get, say, 571.24. And wouldn't you know it, that's one of the things we didn't know earlier. Like, man, this would have been so much better if I had just known this back here, because then, plug in, right? And then just finding the difference. And that's a real simple question, right? That was the last part of question 7, right? So if that had been question 7, we'd get there, we'd be done. All right, well, didn't really work out that way. We have our force, we have friction coming off of it. Apparently the question's so long I'm losing my voice. All right, but we want to find that difference. We're going to find out how much force is actually left over for the push in and pull in to try to make acceleration. All right, so the difference here, what's left over, we've got 1362.76. And that was the whole problem in the first place. So the thing that I was missing, the thing that I needed to get to was to take the net force divided by the mass. The mass we've had the whole way through, but here we are. All right, so net force 1362.76. The mass 201 kilograms. So evaluating here, going back and dividing these, 6.78. Then remember, newtons are a combination of kilograms and meters per second squared. So if we divide out the kilograms, we get the meters per second squared. And there we are. Now, don't be too concerned here. This is a long question, but I believe this is the most different formulas we'll see in any question in the whole semester. We just happened to get to it kind of early. So sometimes it scares people, but they're not going to all be like this.